Hello friends, welcome back to our channel. So today we'll see one more concept in our computer networks, that is TCP header segment. So in our previous session we have seen the TCP service model, that means the key features of TCP protocol, and now we'll see the TCP header segment. So here in the transport layer, so we'll be calling the data as a segments. So here the TCP header segment. So here see the segment means TCP header which is added to data. So this is called a TCP segment. Okay, and this header, so data can be a variable length because depends upon the application. The data size may be varied, the system or application, the data size may be varied, but the TCP header is fixed. Okay, TCP header is fixed. So the size of TCP header is minimum 20 bytes and a maximum of 60 bytes. Minimum of 20 bytes and a maximum of 60 bytes. Right? See, here we'll see what is the TCP header. Okay. So it will be having a 5 32-bit words other than the padding one, right? 5 32-bit words. So every row which I am specifying here will be 32 word. Okay. So the first 32 word will be consist of source port number as well as destination port number. Source port number as well as a destination port number. So this is the thing. Yes. So this will be of 16 bit and this will be of 16 bit. Okay. Next. So source port number and destination port number. As we said that there will be a delivery of data between application to application, right? So that is a one service we have discussed. So here every application will be uniquely identified with the help of a port number. So source port number and the destination port number are important. Then the next one is a sequence number. Sequence number. So what is the sequence number? So the size of this one is a 32-bit. What is the help of this sequence number? Sequence number means to reorder the data. So the number of segments that are being passed to the receiver is the thing. So sequence number mainly used for reordering the data at the receiver side, because we are sending the data. So whatever the data we are sending, that may reach in the same order or in different order. So in order to make that sense, the data should be reordered there. So for that purpose, every packet will be given one unique sequence number. So with the help of sequence number, the packets will be, the data will be reordered. And the next one is a acknowledgement. Acknowledgement. So here the size is again 32-bit. So what is the use of this acknowledgement? Acknowledgement means, so in order, the receiver will be giving an information to the sender that the packet has been successfully received. That is called as an acknowledgement. Okay. So feedback, simply we can say in our understanding words, we can say it is a feedback, or so telling the sender that packet which it has sent has been received successfully. Okay. So along with the data, the acknowledgement will be sent. Okay, in our last session, we have seen three-way handshake. Three-way handshake in the connection establishment. The first one is a synchronization and sequence number, and next acknowledgement along with the sequence number plus one. Right. So that means the acknowledgement is alone not sent. it will be added with the some information and it will be sent to the receiver. And the next one, H length. H length means header length. So whatever the header we are using, the length of the header. So here we have seen the size, header length size is minimum 20 bytes and the maximum 60 bytes. So whether this header is having 20 bytes of data or 60 bytes of data. So to represent that, it will be of 4 bits. 4 bits. Next, reserved bits. Reserved. So these bits will be used for future purpose. These bits will be used for future purpose. So the size is 6 bits. And there will be different flags. Okay, each flag is having a 1 bit. Okay, so the first flag is a urge flag. So URG means urgent pointer. Urgent pointer. So if it is set to 1, that indicates, so urgent pointer should points to important data. That means whatever the data which is being delivered urgently, so to that particular thing the pointer will be points. If it is 0, there is no urgent. That means there is no priority. Simply we can say priority. Next, ACK, which is nothing but acknowledgement. ACK, which is nothing but acknowledgement. That means it will, if it is set to 1, that implies the information, the data will be having some acknowledgement. So it has acknowledgement. If it is 0, no acknowledgement. Okay, the data or information doesn't have acknowledgement. Okay, so this is the representation. Status, we can simply say it is a status. Next, push. So if it is 1, that implies it says the receiver to push the data to the buffer. Okay, push the data without buffering. Push the data without any buffering. Okay, next, RST. RST means reset. So if it is 1, connection should be restarted. So as we said that this is the connection oriented. So before sending and receiving the data, the connection should be established. So if this reset is set to 1, it indicates the connection should be restarted. If it is 0, that's not required. Next, SYN. So this particular thing, SYN, is synchronize. What is this synchronize means? We have seen in connection establishment. So if it is 1, that is connection establishment. Connection establishment. Connection establishment, right? And the next one, FIN, which is a finish. It indicates connection release. So connection should be released. So this also we have seen in our connection release. Okay, connection establishment we have seen SYN, and connection release we have seen FIN, which is a 4-way handshake. This is a 3-way handshake. And the next one is a window size. So window size which is of 16 bits. So all these are 1 bit. All these flags are 1 bit. So all these flags, these are all flags. The size is 1 bit, which gives the status, simply which is a status. Okay. And the next one, so this window size, window means how many bits can be received by the receiver. It shows that we have seen the sliding window, right? So without any buffering, without any delay, without any acknowledgement, how many bits we can transfer to the receiver. So that is the window size. And this is a checksum in order to find out the error correction or error detection. Simply we can say error detection. 16 bits, checksum is 16 bits. Okay. So this checksum is for error detection. Okay, checksum is a error detection. And the next one is a urgent pointer, URG pointer. So here we have seen one flag, URG. If it is set to 1, that means urgent pointer should points to important data. So this is the pointer which is of 16 bits, and if this bit is 1, that implies there is some important data which must be pointed. So this urgent pointer will be pointing towards that particular data. If it is 0, there is nothing. If it is 0, there is nothing. Okay, this is also 16 bits. And all the remaining are optional. Option and padding. Option and padding. So this is of 40 bytes. 40 bytes of data. Okay, so this is a 32, this is a 32, this is a 32, 32 and 32. So 32 bits, it's not bytes, 32 bits. So how much? 32 bits means 4 bytes. 4 bytes. Okay, this is also 4 bytes. This is also 4 bytes. 4 bytes and 4 bytes. See, you can see 1, 2, 3, 4, 5. So 5 fours are 20. So this is an optional one. And apart from this, what is the size of header? Which is a 20 bytes. And the size of this one is 40 bytes. So this is the 40 bytes. Total 60 bytes. So minimum is 20 bytes. So this is a minimum. This is a minimum up to the urgent pointer and checksum. This is a minimum. And there is an option which is a 40 bytes. Optional information. Okay, optional information. If the information is less than 40 bytes, then the padding will also be done. Padding means adding some zeros, dummy bits. Okay, so these are all flags, very important. Urgent flag, acknowledgement, push, reset, synchronize and finish. So source port, destination port, sequence number, acknowledgement, header length, reserved bits, flags, window size, checksum, urgent pointer and options and padding. So hope you understood. This is a TCP header and the complete thing is called as a segment. TCP header and data is called as a segment. So this we can call it as a TCP header segment, or simply you can call it as a TCP header, right? So I'll stop here and hope you understood this one, and this is very important. And the size of each field is also very important. The size of each field. Okay, remember that, practice so that you can easily write in your examinations. Okay, so I'll stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.